Good evening. So my first topic is about the intermolecular forces. So what are intermolecular forces? Intermolecular forces is the sum of all forces between two neighboring molecules. The forces result from the actions of kinetic energy of atoms and the slight positive and negative electrical change on different part of a molecule that affect the neighboring and any solute that may be present. Intermolecular force is measured indirectly using measurements of various properties like volume, pressure, temperature, and viscosity. There are three main categories of intermolecular forces. One is London dispersion forces, second one is dipole-dipole interaction, and the other one is ion-dipole interaction. Hydrogen bonding is considered a form of dipole-dipole interaction. London dispersion forces are the forces that hold molecules together in a liquid. Solid and solution phases are quite weak. They are called generally London dispersion force.
All molecules interact with each other through London dispersion forces or induced dipole interactions. In this figure, a 2-atom molecule collides with a 3-atom molecule. The electron cloud of the first molecule repels the electron cloud of the molecule it strikes, causing a displacement of some electron density away from the nucleus. The nucleus is then poorly shielded by its own electron and attracts the electron cloud of the first molecule. Both molecules now have a small dipole moment that was induced by molecular collision.
Dipole-dipole interactions have molecules with permanent dipoles that can interact with other molecules through dipole-dipole interactions.
Here's the structural formula of formaldehyde in addition to the attraction London dispersion forces. We now have a situation where molecules are polar. We say that the molecule has a permanent dipole. Now the molecules line up, the positive ends up near to the another molecule's negative end. Since the dipole is permanent, the attraction is stronger. However, we only see this sort of attraction between molecules that are polar. It is usually referred to as dipole-dipole interaction. The strength of this attraction increases with increasing total of number of electrons.
I'm going to talk about what is a hydrogen bond. A hydrogen bond or hydrogen is bonded to very electronegative elements such as fluorine, oxygen, and nitrogen. Is highly electron deficient. It acts as a Lewis and interacts with basic sites in other molecules. The hydrogen bonding interacts is stronger than dipole-dipole interactions. Again, it adds to the existing London dispersion forces to stabilize molecules in solution.
Here is an example of chemical reaction wherein a hydrogen is bonded with oxygen and fluorine forming a hydrogen bond.
Ion-dipole is the attractive force that results from the electrostatic attraction between an ion and the neutral molecule that has a dipole. Most commonly found in solutions, a positive ion or cation attracts the partially negative end of a neutral polar molecule. Kinetic molecular theory states that the average amount of empty space between molecules gets progressively larger as a sample of matter moves atoms and molecules, and this becomes stronger as the particles move closer together. Now I'm going to talk about properties of liquids. The first property is cohesion. One of the reasons oils are good for this application is because they have low cohesion. Liquid molecules don't interact particularly stronger with each other because the intermolecular forces are weak. The second property is adhesion. Adhesion is the tendency of a compound to interact with another compound.
One example of an interaction with high adhesion is that between water and glass. Both water and glass are held together by polar bonds. Therefore, the two materials can also form favorable polar interactions with each other.
Now I'm going to talk about surface tension. What is a surface tension? Surface tension is the energy or work required to increase the surface area of a liquid due to intermolecular forces. Since these intermolecular forces are depending on nature of the liquid.
As an example of a surface tension, a paper clip can float on water because of surface tension. Surface tension also allows insects such as this water strider to walk on water.
Now let's talk about cohesive and adhesive forces. Cohesive forces are those forces hold the body of a liquid together with minimum surface area, while adhesive forces are those that try to make a body of a liquid spread out. So if the cohesive body are stronger than the adhesive forces, the water will maintain its shape. Viscosity is another type of bulk property defined as liquid's resistance to flow. When the intermolecular forces of attraction are strong within a liquid, there is a larger viscosity. An example of this phenomenon is a race between water and honey. Obviously, one would expect water to easily pass honey. The fact reveals that honey has a much higher viscosity than water. Vapor pressure is a measure of the tendency of material to change into gaseous or vapor state, and it increases the temperature. The temperature at which the vapor pressure at the surface of a liquid becomes equal to the pressure exerted by the surroundings is called boiling point of a liquid. Boiling point is the temperature at which the vapor pressure of the liquid equals the external pressure surrounding the liquid. Therefore, the boiling point of a liquid depends on the atmospheric pressure. The boiling point becomes lower as the external pressure is reduced. Molar heat of vaporization is the amount of heat necessary to boil 1 mole of a substance at its boiling point. The molar heat of vaporization is an important part of energy calculations, since it tells you how much energy is needed to boil each mole of a substance on hand. The molar heat of vaporization of water is 40.7 kilojoules per mole. To get this heat of vaporization, you need to divide the molar heat 18 grams per mole.
This is the formula of molar heat of vaporization. Q is the total amount of heat involved. The next one is the symbol for the molar heat of vaporization. And the mass over the molar mass is the divisor to get the number of moles of substance.
Now let's talk about properties of solids. The first property is crystalline solids. Crystalline solids are those in which the atoms, ions, or molecules that make up the solid in a regular, well-defined arrangement. The next property is about amorphous solids. Amorphous solids do not have order in their structures, though their molecules are close together and have freedom to move. They are not arranged in a regular order as those in the crystalline solids. Molecular solids are made up of atoms and molecules that are held together by London dispersion forces, dipole-dipole forces, and hydrogen bonds, characterized by its low melting point and flexibility, and are poor conductors. Covalent network or atomic solids are made up of atoms connected by covalent bonds. The intermolecular forces are covalent bonds as well, characterized as being very hard with very high melting point and being poor conductors, for example, diamonds and graphite. There are 4 types of crystalline solids. Number 1 is the ionic solids. Ionic solids are made up of positive and negative ions and are held together by electrostatic attractions. They are characterized by very high melting points and brittleness, and are poor conductors in the solid state. An example of ionic solid is table salt or sodium chloride.
As you can see in this figure, graphite has only 2D hexagonal structure, and therefore it is not hard like diamond. The sheets of graphite are held together by only weak London forces.
Metallic solids are made up of metal atoms and are held together by metallic bonds, characterized by high melting point, can range from soft and malleable to very hard, and are good conductors of electricity.